Here is one of two EIZO Flexscan SX3031W monitors which are not working. The one we see here beeps 4 times after pressing the power button, and that's about it. The other one starts, but the picture is very distorted. So let's clean it up a bit and see what's inside. Refurbished 15/10/2015, no picture. Well, look at that. That is quality. I thought Dell monitors had good build quality, but this is next level. We see that there are a lot of capacitors on what looks like the main power supply board, because that's where the power comes in. It has a lot of capacitors and houses a large transformer. So let's check those capacitors first. Those two are fine at least. Now let's take out the board and check the other ones. Let's discharge the capacitors first to prevent any nasty surprises. These capacitors are connected in parallel, as we can see from the tracks on the PCB, so they add up to quite a large value. I checked every single capacitor I could find, even desoldered some to check them out of circuit, but they all measured fine. The board has a few MOSFETs and components that look like MOSFETs, but are actually 2 diodes in one package, and none of them turned out to be shorted. So let's move on to the next board. These aluminium, or as some people say aluminum, surface mount capacitors are known to be not so reliable, so let's check those. I wasn't too sure what to make of the measurements, so I desoldered a few to check them out of circuit. They also turned out to be fine, so let's move on to the next board. This board must be providing power to the LED panel itself, considering the many transformers and the warnings for high voltage. The plastic covering is glued to it with thick double-sided foam tape, but it has lost its stickiness. We'll replace that later. We may reduce transformer hum a bit by doing so. I measured the cable going to this LED driver board and it measured 24 volts. So let's see if we can measure some voltages when we put 24 volts on the board. No voltage is to be measured here, probably because the board needs an activation signal, and to be honest, I feel a little uncomfortable putting seriously high voltages right in front of me, so let's move on to the last board we haven't examined yet. This board apparently has its own cooler fan, which means it might get quite hot. So lots of expanding and shrinking there. Let's get it out. Since we have two of these boards, let's put the multimeter in diode mode and see if we can find some difference values between the boards. The diode mode basically shows the voltage needed to push a small current, like 1 milliamp, through the circuit between the probes. So we could interpret that as the resistance between the 2 points we are probing. If there is a difference between two boards that should be the same, it might be an indication of a failing component. We do find some differences, and maybe it's time to do some searching on the internet. So what I found browsing some forums is that more people have experienced similar problems and that professionally reballing the Altera chip solved their problem. Reballing is done when the solder connections of the chip are deteriorated and are renewed by heating the chip, removing it from the board, adding new solder and resoldering the chip. What is also possible is just reheating the chip to make the current solder reflow and thereby fixing the connections. Since a professional reball job will cost a pretty penny, probably £1, let's have a go and reheat the chip ourselves with the hot air station and see if we can reball the chip ourselves without calling it professional. So after reheating it for a couple of minutes at 380 degrees centigrade, about 700 Fahrenheit, let's see if it has made a difference. And it did! Let's do the other one as well. For this one I took a timer to heat it up for 5 minutes. If that works well, you can do the same if you want to give it a try with your own monitor. And that worked well. Look at those colors. These really are worth saving. Which we did. 2 beautiful monitors given a new lease of life. Thank you so much for watching. Please subscribe to my channel and I hope you will join me in the next video. Bye then!